Hello there, my name is Martin Conway from Contomac Limited, and I'd like to first of all to thank Number 7 Contact Lenses for allowing us to present to you these short series of videos on contact lens materials and their properties. In this clip, we'll be looking at wettability. Contact lens wettability is a crucial component of wearer comfort in contact lenses. A wet surface will allow the lids to slide smoothly over the surface of the lens without irritation to the underside of the lids. Also, a wet surface is much more difficult for contaminants to adhere to than if dry patches are allowed to form on the surface of the lens. It may surprise you to know that the average human eye will blink 11,000 times during the course of a normal day's wear. So it's critical that we keep this surface as clean and as wet and lubricious as possible. We measure wettability in terms of wetting angle, and there are various methods of doing that. 3 are acceptable in the contact lens industry: Wilhelmi plate, captive bubble, and the sessile drop. Now, it'll get rather confusing if we try to explain all 3 in completeness. So what we've chosen to do today is explain in detail how we perform the sessile drop test, how we do the measurements, and what significance those measurements have on wearer comfort and your choice of material. The sessile drop method involves placing a measured droplet of water onto the polished surface of the material to be measured. The more resistant the material is to the flow of water across the surface, the more weight of water it will suspend above it. And we measure the angle at which the droplet makes with the contact surface of the material, and that determines the contact angle, as the name suggests. The higher the angle, the less wettable the material. We'll now look at a short video clip showing one of our scientists conducting the sessile drop measurements in the laboratory, and I'll talk you through the various stages of the procedure. That gun you see there is an anti-static device that removes any static electricity from the surface after the lens has been blotted. Obviously, the rubbing can actually generate static on the surface of the lens. Surface of this button has been polished to match that of a finished lens, and then a carefully metered dose of 10 microliters of water is gently introduced to the surface of the material from the syringe. There's a light source that you can see there to the right, which will shine through the sample, and the image will be picked up by a high-speed camera to your left. Here's a view through that camera, and it's that angle that that droplet forms that we'll be measuring. Here we can see that image saved to the computer, and a baseline is actually dropped onto the image to eliminate that reflection that you can see there that might give us a false reading. So once that baseline has been established by moving the cursor, the computer will superimpose a circle to match that of the sample, like so, and then the contact angle can be measured against that the tangent to that contact point and the baseline. Now, there are 2 measurements we make for the sessile drop technique. One is called the advancing angle, and one is the receding angle, and we'll see that in use now. The advancing angle is measured as the droplet is being introduced to the lens and expanded over the surface of the lens. And that really gives us an idea of how that material will behave as the lid passes over it to establish a tear film on the surface of the lens. We can see the droplet growing and then being withdrawn and expanded. And you can see that the wetting angle, the contact angle between the droplet and the surface changes with each of those movements. So as I said before, the advancing angle will indicate how readily the surface will wet as the lid passes across it. The receding angle is important also because it really gives us an indication of how stable that tear film is going to be after the blink. So we've covered the measurement of wetting angle, contact angle using the sessile drop mechanism. What else can we tell you about the surface characteristics of a GP material? Well, there is one other complication in as much that we also measure the lens in its dry form and also after soaking for up to 7 to 10 days. What difference can that make, you may ask? A lens is inert, it doesn't really change, but that's not the case. If we look at the slide below here, we can see that a modern GP material will contain up to 10 or more different monomers. Some of those monomers will be hydrophilic or water attracting. Some will be hydrophobic, such as silicone, which will repel water from the surface. So when the lens is first made, the surface will contain a mixture of hydrophobic and hydrophilic materials. And this combination will affect the wetting angle. What might appear to be a stable inert surface is in fact very active at the molecular level. And if that material is now soaked in a liquid, what will happen is the hydrophobic species, the hydrophobic parts of the matrix will turn away from the surface, and the hydrophilic will be attracted to the surface. Now, this process can take up to 7 days or more, and that's why we always take two measurements, a soaked and a dry measurement. And there are quite a huge difference in the measurements we obtain. Now, in the next slide, what we can see is the dramatic difference in wetting angle that occurs over a 7-day period. You can see that the majority of the change takes place in the first 48 hours, which coincidentally is about the time it takes for the lab to ship the lenses to you. And so if the lenses arrive in a wetting solution, you can be assured that the majority of that change, that conditioning, has already occurred. If not, you might well be advised to put the lenses into soak prior to the patient collecting them. If not, you will find the patient will complain, particularly if it's a replacement lens, that the lens doesn't feel as good as his old lens, or it may even require extra cleaning during that first week or so, as the surface is drier and will tend to attract more deposits. So this conditioning process is essential. And you can see there the difference in the wetting angles, the quite dramatic differences that tend to occur after 7 days or so. Now, this occurs to all manufacturers' materials, and so it's not particular to one type of material or one particular manufacturer. So as you can see here, although it takes 7 days, the majority of the change occurs after the first 48 hours. This change is reversible. So even if you have a lens that is fully conditioned and wettable, and the surface is working well and the patient is happy, if any lipid which is hydrophobic is allowed to come into contact with the surface, i.e. the patient doesn't clean the lens properly and is left on the surface for any length of time, this process of change can reverse. And the lipid, being hydrophobic, will attract the hydrophobic species of the monomer to the surface of the lens. And you'll actually develop a dry patch underneath the lipid. The patient will come in complaining of smeared vision, and you'll spot the lipid, take the lens out, you'll clean it with a surfactant, and on inspection, visual inspection, it will appear to be perfectly clean. When you put the lens back on the eye, however, after blink, you'll notice that there's a dry patch, exactly the same shape as the lipid you've just removed. The initial opinion of most practitioners is there's a fault on the surface, and they will return the lens to the manufacturer. They will return it, hopefully, in a wetting solution. This will allow this change to occur. The manufacturer receives the lens and sees no problems at all with the surface. This could be avoided if the practitioner just cleaned the lipid off the surface of the lens and allowed the lens to soak for 48 hours. As an experiment, I tried this on my own eye. I took a perfectly good scleral lens. I put some Vaseline jelly on the surface of the lens and left it over a weekend. On the Monday morning, I came in and I cleaned the Vaseline gel off the surface of the lens and put the lens on my eye. And we can see that post-blink, we can see the dry patch appearing exactly where the jelly, the Vaseline, was actually in place. In summing up, although this presentation is concentrated on the sessile drop method of measuring wetting angle, the principles apply to all three methods. For a practitioner to be able to compare like with like, you'll need to know what method was used, whether the number you're referring to is the advancing angle, the receding angle, and also whether the material measured was actually wet and soaked for 7 days, or whether it was dry. And should dry spots appear on a material, then remove them and allow the reconditioning process to take place. Well, I've hoped you have enjoyed this. This is the second in the series on material properties from Contomac, and I look forward to seeing you for the third one. Thank you. Bye-bye.